Hello everyone. So in this video, we are going to solve this question, and this question is based on the length of intercept made by the transverse tangents on a common tangent, direct common tangent, and vice versa. For that, we have the two circles given. That is the circle 1, that's C1, whose center is origin and the radius is 3. Equation is x squared plus y squared is equal to 9. The second circle is centered at 2, 5 and radius is 2. Now, their pair of common tangents to the circles are intersected by the pair of transverse common tangents at A, B, C and D respectively. So we have to find out the length AB, that is the length of the intercept made by transverse tangents to a direct tangent, and again we have to find the length, that is the AD, the length of the intercept made by direct tangents to a transverse tangent. So I have two circles here, and I have already done some constructions so that our work will be easier. So I have the circle C1 here centered at C1 and circle C2 over here centered at C2. So these green tangents, you can see that there are transverse common tangents, and these blue tangents over here are the direct common tangents. So if we say that the direct common tangent length, so either you can find the kj, this kj, which is the direct common tangent over here, and the pq, they must have the same length. And why it is so? Because you know that along this line joining C1 and C2, if I join the straight line, these two lines or the two tangents we extend, they will intersect on the same line joining C1, C2. And this entire picture or the entire scenario will be symmetrical about the line joining C1, C2. So it is like we have these 2 points, two lines are intersecting over here, and we take this line and we just fold along this line C1, C2, it will be a symmetrical picture. So we'll use this fact to calculate easily. So first of all, the PQ is the length of direct common tangent. We also call DCT length. And the PQ formula, the length of direct common tangent, is given by this D square minus R1 minus R2 the whole square, where D stands for the distance between the two centers of the circle, that the distance C1, C2, and RS is the length of the LM, that is the transverse common tangent, and the length of this transverse common tangents are given by the formula square root of D square minus R1 plus R2 the whole square. So we have this known, these two known facts are there. We will use it to formulate the lengths of the intercept made by the transverse common tangents over the direct common tangents and vice versa. So for that, what the construction we just proceed, I am just taking this AP length, let's say A, and this A length is also A. Why so? Because you notice the AP is the length of a very small tangent drawn from A to the circle C1, and the AL is the length of tangent drawn from the same point to the same circle. So both lengths of tangents should be A. In the same way, I'm taking this length, the BR, and the BQ are, let's say, B. Why so? Again, we can understand that the B is the point from where we are dropping two tangents, the BR and BQ, over the circle 2. And we already understood, or maybe we can feel that they are symmetrical. We can prove it also geometrically, but this is not the scope of or the target of this video. So we know that they're symmetrical. So we'll just take this TK and TS are also of the length A, and similarly the DM and DJ are also of the length B. So in this way, we have this AA and BB and so on, and we will use this to find out the length AB. What is the length AB? The length of the intercepts made by the transverse tangents to a direct tangent. So I selected the direct tangent PQ, and over here you notice that this is the transverse tangent and this is another transverse tangent, and they are intersecting a direct common tangent here at A and B. So I have to find out the length AB. Similarly, we have to find the length TD, but by symmetry they will give the same length. So how do we find it? So can we formulate directly without this particular case of these two given circles at centered at 0, 0 and 2, 5 with radii 3 and 2. So how do we generalize it? So see here, I'm taking this picture below. I don't have space here, so wait for that. So here I have the picture. Notice, so I know that from A, again I can take two tangents, one on this circle C2, this side, and the other one on the same circle C2, this side. It means one is the tangent length AQ, the other has a tangent length AM. So I can write this length AM is equal to the AQ. But notice the AM, I can write it as the AL plus LM, and AQ over here I can write as AB plus BQ. So AL is actually A, so let's write it. AL is A plus LM, and this is AM. AM, I did a mistake here, that should be AB, not AM. AB plus BQ is obvious there. So this is AB and that is BQ. BQ is B. So this is the tangent I drew from A to circle C2. The similar thing we can do for the tangent drawn from B to this bigger circle C1. So you notice what we can write: the tangent from B to this point S and B to this point P. And here from B I can write is B, this tangent, the BS and the BP. So I can write BS is equal to BP, and BS is nothing but, I can write B, the small b, plus RS, and the BP I can write the AB or BA plus small a. Now you notice from these two equations we can do something. What we can do something? We can understand that the RS and LM, you see, the RS is the direct common, the transverse common tangent, and also the LM is the transverse common tangent, and each transverse common tangent have the equal length. It means LM and RS are of the same length, so I can write them as LM or RS, and similarly AM and BA. This is again, I wrote AM here, that's the mistake. There's the AB and BA I can write. So now we can add them together so that we can see the A and B will cancel from each side. So we get here 1 plus 2. That means I have A plus B on the left hand side with LM plus RS, and A plus B right hand side as well with AB and BA. It means the A plus B and A plus B will get cancelled, and so we are getting the twice of LM is equal to twice of AB. You can recall we have to find out the value of AM. So again I've written here, so this is AB. So AB is nothing but the LM. So what is the take away from here that the length AB, which is the intercept made by the transverse common tangent on any of the direct common tangent, is equal to the transverse common tangent itself, because LM is the transverse common tangent length. So the AB is nothing but, if we do the question here, the AB is nothing but the length of transverse common tangent. So it can be LM. So let me write here the length of transverse common tangent. Transverse common tangent. Now you can find it by just using the formula, and length of transverse common tangent formula is this one, this LM or RS, you notice. So we can find the distance between the two centers, and the radii we have already given, so we can find it. So let's find it out, and then we go for the direct common tangent intercept. So for that, I have D is the distance between the centers, and distance between the centers is what? 2 square plus 5 square, that is 29. So D square is nothing but 20, sorry, this is for D, and I need D square, that is 29. Now I have to find out the radii 1 plus radii 2, you see that here. So radii 1 plus radius 1 plus radius 2, that is the sum of radii, I mean to say, that is 3 plus 2, that is 5. So AB length is the length LM, and LM can be found out by this formula. Now let's prove it. We can also understand that what will be the length of intercept made by the direct common tangent over the transverse common tangents. So this is the line I have to find the length of, the AD, the line segment AD I have to find. You can notice this is one direct transverse common tangent, and the intercept on that is made by this direct common tangents. So basically you have to find out the length AM. Okay, so what we understood, that this length was, I assumed B, this is B, so in that way this is also B, this is also B, and so this is A, this is A, and so I have to find the AD. So AD I can write it as, you notice, AM plus MD. But you also notice the AM I can write the AL plus LM and plus MD. Now let's give them values. So that is actually, it is A plus LM is, we just found LM is nothing but AB, and MD is nothing but B. But you also notice one thing, the I can also write as the length AP. So this is AP or PA, this is AB, and the B I can write as BQ. This is BQ. So we just get AP plus AB plus BQ with nothing but PQ. So we prove that the AD, the length of the intercept made by the direct common tangents on any of the transverse common tangent, is equal to the length of the direct common tangent itself. So for that, we again use this formula here. For the direct common tangent, there is a PQ, and all the things are known to you. There is a D, R1 and R2, and from there we can evaluate the AD as well, and we already evaluated AB. I don't think it is need of calculating this thing by me, because I hope all of the calculations after this you can carry on. So thanks for watching. Stay math active for the other videos. Thanks.